Good evening, everyone. My name is Tushar, and I'm from HFCL. From any one of you who do not know what HFCL is, we are an telecom and networking original equipment manufacturer, right from optical fibers to all the networking gears with respect to access points, switches, routers, and the management platform. We deal within all these product portfolio. So in the next 20 minutes, what I'll be discussing is with the lessons which we have learned from one of the largest campus Wi-Fi deployments, a deployment which scaled like almost 12,000 enterprise access points in India, and the lessons which we have learned while we were working on this deployment. Now, when we talk about Wi-Fi deployments and campus deployments, we majorly focus on product specifications, might be radio capabilities, throughput, or the latest Wi-Fi standards. But when the deployment reaches this scale, the question completely changes and the conversation flips. One of the few questions which we basically ask is, how do you design for tens and thousands of users? How do you maintain a quality of experience and that a consistent quality of experience across hundreds of buildings? And most importantly, how does the network look like when it goes live? So we'll try to answer these questions through some real operational data, which we have captured during this deployment as a case study. And then we'll be concluding with some of the practical engineering lessons which we would want to share with all of you. So before I share those operational data and get to the case study, let me just take a few minutes just to discuss how the evolution of campus networks has been. And all of us might be agreeing that it is not the same the way it was, let's say, 5 to 10 years ago. Today's campuses are not just expecting a simple Wi-Fi coverage to a similar to their classes or academic buildings. Today's Wi-Fi infrastructure is basically an underlying platform which is serving your entire digital service which you're running in the campus, right? And we take an example of, let's say, classrooms, right? They are not now limited to just sharing presentations or a simple web browsing, right? You have tens and thousands of students which are continuously using different type of applications, be it media streaming platforms, online learning tools, right? Even immersive technologies in few of those labs, experimental labs or engineering labs. And all of these applications demand different types of requirements in terms of latency, bandwidth, or throughput within that single network. And again, these campuses are now slowly and steadily adopting IoT in terms of building automations, monitoring, surveillances, right? And these IoT devices, as we discussed in the summit itself, they just not focus on scale. They also focus on coverage, and they have their own set of challenges and requirements with this Wi-Fi network. And slowly and steadily, we are also seeing some immersive technology being experimented in the campus institutions as a part of their experiments. So again, they also require high amount of reliability, very low latencies. So the underlying factor is that now the campus network is just not a simple Wi-Fi network. It is basically a very dynamic infrastructure which keeps on evolving and it keeps on asking you difficult question in terms of network connectivity. Now, as these applications are evolving, we are also seeing that there are certain complexities which comes into this deployment, right? And one of the few misconceptions which we always have is it's always about scale. And when we look at it, scale is just one part of the equation. We majorly see that there are four major dimensions to this campus network complexity. The first one is a user base, of course. You do not have just students which are there in the campus. Apart from students, you have your faculty members, you have your administrative staffs, you have the visitors who are visiting the campus, you have contractors. And all of these users are basically expecting different types of onboarding services to their Wi-Fi. You cannot give them the same onboarding journey to all of these users. You have to differentiate, right? All of these users are being governed by a different security policies, different authentication policies. So you have to maintain that diversity in terms of catering to this diverse user base. With that user base, the other part of the complexity is the devices which they carry, right? All of these users are not using the same devices. They are using different type of devices, since BYD is always a concept in campuses. And the second set of devices, as we talked about, and the real challenge also comes with the IoT as well, right? Then you have your legacy devices, which you have to cater to the Wi-Fi campus, which equally makes the equation very complex. The second part is the applications, as we talked about. So it's not just merely now limited to web browsing. You have even your exams are happening online in these campuses, right? You have bandwidth intensive media application being played. You have online collaborations tools. All of these is being accessed simultaneously by thousands of users at the same time. So it's not just about the complexity which these applications, the demand which these applications come from for the network, but also that you have to maintain that reliability, that they are always available when users are actually wanting to access it. The last part is obviously the security part, right? You have to maintain a distinction in terms of authentication, in terms of continuously monitoring your network, so that each kind of security bandwidth, attack surface which is being increasing, you have to cater to that as well. So let me just take a moment to tell you about the university which this case study was happened. And it is one of the oldest and the largest universities in India, which has a history back of around 100 years. The entire university is a kind of a distributed multi-campus architecture. So all of these 90 plus colleges are distributed across the city, right? You have around 86 academic departments which are being served. You have more than 350 different buildings spanning inside these colleges, which are requiring the Wi-Fi connectivity. On top of it, you have 125 residentials, which spans across the faculty residence and the hostels, which are serving to these students. And in total, you have more than 160,000 students, which are accessing your network, which are accessing the Wi-Fi, in addition to the faculty members and others, user base, which we talked about. So we often, joke around within when we were talking about this deployment, that it's not just your regular enclosed campus deployment where you have handful of buildings. It's typically like designing a metropolitan network where where the distribution scale is so much that you need to define certain stringent infrastructure in terms of Wi-Fi, so that user experience is completely consistent. So there were a couple of design objectives which, as we discussed the challenges, that kind of shaped our design objectives when we were working on this deployment in terms of our planning phase. And the challenges kind of resonates to our design principles, where the first design objective was the scale, right? We just wanted to not wanted to serve the current user base, but we wanted to plan for the next 5 to 10 years as well. So the ask of the university was primarily on that front, that we are designing a network which is at least will stay for the relevant for the next 5 years or maybe 10 years, right? The other aspect was the security part, because every different user was put it across a different authentication method. They had their own sorts of requirements. So security was again another parameter. Reliability is again that, students do not measure RSSI. They do not measure throughput. For them, it's like my Wi-Fi is not working. That is a simple problem which can degrade the entire experience, right? So you need to maintain that reliability factor as and when serving so many users at the same time. And again, the quality of experience which we talked about. So these were the major 4 design principles which we talked about. I'll just take a couple of more minutes to help you explain the architecture at a high level, how the entire infrastructure was distributed. At primarily, you had 3 domains. The North Campus and the South Campus had its own. Yeah. So the North Campus and the South Campus, they had its own switching hierarchy, right from the core switches to distribution to access switches, right? Uh, the third domain was the off-campus colleges, which was basically the affiliated colleges, which were distributed across the city. and they were connected to an MPLS network, from a centrally management platform, having their own gateway and distribution switching network separately, right? So all of these basically three categories of sites, they were all being managed through centrally at the cloud, where all your management platforms, all your NAC systems, everything was centrally being managed through the cloud. So that was their high level architecture going way, right? So the next few slides, I will be sharing a few of our insights where we had put the network onto test for just 1 week. Since the data was so huge, we wanted to conclude it in a very concise manner. So we just took 1 week of data and we wanted to present those results to you over that 1 week. I'll just take a water break. Sorry. So over a week, you had around more than 7,500 access points actively working, serving this amount of user base with almost 50,000 daily users connecting to this network and around 18.5 TB of data being consumed every day, right? If you look at the graphs very closely, the graph to your left one, you will see a sudden spike of users on a day of Tuesday. And that was merely because Tuesday was a holiday. But interestingly, if you see, the data consumption is not that significantly low, right? That eventually tells you that the Wi-Fi was not just serving your classrooms. It was also being accessed through hostels, residential blocks, your faculties were up. So the network was not sleeping, right? If you consider that the majority of your Wi-Fi consumption will happen in the classrooms, that's the misconception, we used to carry, right? So it is not related to your academic calendar. Your users will be up, your Wi-Fi services will be used any time of the day, any time of the week, regardless of what sort of calendar offs you have. Now, another interesting factor when we were analyzing the weekly behavior, there was a consistent pattern which we, kind of observed. And that again tells you about certain design factors or design consideration while you are working, deploying on these network is averages will not eventually work for you all the time. You need to dimension your infrastructure in terms of how do you handle the busiest periods in an entire day, right? And when we were analyzing this network for every day for the last 7 days, what came out was that 12 to 1 was the busiest hour, across the day, where you've almost had half of your connected users who were actively, present in that network and they were accessing the services, right? So a basic design element is that you need to you need to plan your network in terms that you are actually handling the peak behavior, the peak hour or a peak duration of your network very stringently. Otherwise, you will receive certain degradation feedbacks of your network, since if it is designed for averages, right? So yeah, that's the underlying messaging which we wanted to give. The other part of the question which we wanted to answer was that how users are utilizing the spectrum. That was the question which we had, and to our not to our surprise, we only fact that 2 out of 3 clients connected on 5 gigahertz. Very expected behavior, very positive at the first glance. That all your capable clients are connected to the 5 gigahertz, and and that is the expected behavior. But you still had 33% of the clients connected to 2.4, and that is not an insignificant number, to be honest, right? So you had those legacy clients, you may be having some of the IoT devices which are still latching onto 2.4, and that is still interesting that you cannot just ignore 2.4 and just simply disable 2.4 since it's been legacy, right? The other side of the coin is that it also gives us a strategic importance to 6 gigahertz, because as more capable clients will be joining the network, they will be latching on to the 6 gigahertz, might be a preferential one, and then you can leave 2.4 and 5 for your legacy. So the key message from this slide is not that 5 gigahertz is winning. It's that at present, when we are at a transition state, all the three bands are very important in your deployments. You cannot just simply ignore 2.4 since it is being a legacy one. The other part of the question after the spectrum utilization was how the load was being distributed in terms of the access points which were deployed. Now, the general conception remains that if you have deployed access points uniformly, the load will eventually be uniformly distributed. And that is again a misconception which got eroded, because 95% of the APs which you are deployed right now had less than 250 clients in a 24-hour window, right? And you had almost very less percentage of APs which were carrying the bulk of the traffic, which was almost 35% of APs which carried the bulk of the traffic, with only 5% carrying more than 10 GB. So user distribution and traffic distribution is never uniform, at least in real deployments. That was, would be learned from this large deployment. Now, also one of the factors is, if you look at these two tables, the table to your left, sorry, yeah, the table to your left will eventually tell you that, so this has been taken over the course of one day, 24 hours. So table 1 will show you the APs with the highest traffic, and the table 2 will show you the APs with the maximum clients. The interesting thing to observe here is that they are not the same, right? The APs with the highest client count may not be the APs with the highest traffic. And that is which was very interesting for us, right? Most of your traffics was majorly coming out from classrooms, libraries, your areas where self-learning used to happen. Pretty much sometimes from the hostels as well. The lighter part remained the academic blocks, where faculty resides, or the residential blocks where the Wi-Fi activity was not that prevalent. But the important point here to note is that, as I said, your heavily densely populated APs may not the ones who are consuming the most data. So you need to plan your RF planning in that perspective. That it's not just about the user base. It could be also about what type of application will be consumed at what areas. Another interesting factor which came was, and I'll be doing a bit quick. I have just 2.5 minutes left. So uplink traffic also showed a good amount of significant during this deployment. We had around 10% of the APs who were actually more loaded in terms of comparing with having higher uplink than downlink. And that's a good number. And almost 30% of these APs had a significant, close to, I would say, more than between 25 to 50% of uplink traffic as compared to downlink traffic. So again, a very interesting factor that typical enterprise deployment always, have their mind into downlink, but you do not have to think on the uplink factor as well. The other factor was the mobility patterns. Of course, you had such a wide campus, you will be expecting roamings. We did expect roaming, but that too got limited to handful of APs, at least from the larger part. So 44% of the clients which got connected, they were roaming, but the limited mobility was there, with close to 1 to 5 APs. And that was the count. And probably 10% of your clients were roaming across more than 25 APs. So still, I would say these patterns will eventually see a more turn. But yes, mobility is another factor which kind of brings out how these campus deployments takes into place. Okay, so quickly, I have 1 minute, 16 seconds. I'll be sharing a few lessons which I just wanted to share, from this deployment. What did you learn? First and foremost is non-negotiable in terms of RF designs. You can make use of tools, of predictive tools, but physical surveys are not replaceable. You cannot replace physical surveys. Every material, every building, every user type is different, right? A difference in material can, hamper your Wi-Fi service in a broader sense. So physical surveys are very important. Uh, RF surveys are part of your process. They do not end after deployments. They have to be a continuous process, even if your network has gone live. It's a continuous learning process. We are also, till now, are eventually making it a part of our process so that we have to make changes accordingly as the network is evolving, right? The other part is always a hot topic of 2.4. It's something which is we want to get away, but we cannot and we should not. But we have to be very, very balanced in terms of whenever we are designing the network, it has to be very strategic on which parts we want 2.4 to be heavily populated, right? You should always be careful that it should not be too much overlap. What we carry is not more than 10 to 15% of overlap when we are designing at least 2.4, so that the sticky client behavior is something which you can take care of, right? Strictly avoid 40 megahertz in 2.4. I think that has become a slowly standard in deployments. Doesn't help. The last part is the SSIT design. Very important. You have to make it a plan that SSID designing has to be the very first post before even you're deploying, because every additional SSID will eventually consume your airtime. So planning a SSID, how many SSIDs I have to deploy for such diverse user base is again very important. 1 minute more. Infrastructure lessons quickly. Power and connectivity is really important. You need to make sure that your power budgets are in place, because ultimately if the APs are not performing because of the power budgets, it's something which the design phase has lagged. Design the user journey very early in your deployment, how the users will be connecting, what sort of onboarding journeys they will be going through, what could be the friction in their onboard journey. All of this has to be the part of the plan before even you start deploying. Never underestimate your core services, all your DHCP services, AAA services, because when they will be needed the most at the time of your peak behavior, peak hour, they will be the ones, if they get choked, your network will eventually not work. Right. At the end, I think very generic lessons from an operation standpoint. Such a large scale of deployment has to be managed centrally. It becomes a very difficult task if you're having different or standalone management platforms. That is one. Focus on very measurable, actionable items. You cannot have alarms for each and every event which is an anomaly. You need to define your alarm systems very early in the system, because alarm fatigue is actually very real. Think of that network admin who has to see hundreds and thousands of alarms even in the span of 1 hour. So you need to design your alarm systems in that way so that it is actually those critical events which needs focus, right? And last but not the least, not just design it for today, design it for tomorrow. So have some sort of scale in mind for the next 5 years, and focus or convince your customer that you are not just designing it for today. We are helping you to design it for the next 5 to 10 years. So that is it. Thank you, everyone. I'll be happy to take questions.
Thanks, Tushar. I think we should be happy that I think this is all HFCL team is mostly based in India. So you can say it's an Indian company offering this scale of solution. So
play India-based company.
yeah, so it's nice to see something diverse. Yeah. So maybe we can take one question in the interest of time before we break for tea. Anybody has a question? Question, comment? Nothing there. So, Tushar, maybe just to ask, there are other campus deployments across the globe. So, did you see any noticeable differences? I'm sure some of your team members studied that. So, did you see any noticeable differences between those and yours? Is there something that you had to do differently here compared to what people had to do in other geos?
I think the stark difference was in terms of the Wi-Fi. They were mostly Wi-Fi 6E and Wi-Fi 7 deployments. That is the generational difference was there. From the user base of point of view, from the devices which we're being connected to, that is something which is a stark difference. You do not see a Wi-Fi 4 or even a Wi-Fi 3 generation device international. At least you might find the least you will find Wi-Fi 5, as to my experience. But here, at present, in this deployment, we had often seen even a Wi-Fi 3 device being connected. So that is a very stark difference, and at least I see is very prominent in India, that you have such diversity of user bases which are connecting onto your network. And again, the lower generation will have more airtime, they will consume more airtime. So that is one stark difference and a challenge, which I think was completely. And I saw one of the podcasts from Canada as well, where they had interviewed someone who was deployed a 4,000, 5,000 access point network in US. So all of that was they were talking about was Wi-Fi 6 and 7. So we do not have that kind of, I would say, leverage. But yes, that was a difference.
So thank you, Tushar.